Welcome. This is our first lecture about Introduction to Statistics. We will be talking about what statistics is. Statistics with the plural S and with the uppercase S in the beginning is a science. It's a science about data. The data could be numerical and sometimes nominal, meaning something that is not numerical, as in gender, zip code, or color. In either case, the data is collected for the purpose of organizing, for the purpose of presentation, and when we do that, we call that descriptive statistics. In case we are analyzing data once it's collected and making inferences and conclusions, then we call it inferential statistics. Statistic as a word without being with the uppercase S is usually something we calculate from a sample. A sample is a collection of items from a population. When we are talking about a population, we are really don't mean living and breeding people. We mean something that would be consisting of numbers or measurements or counts, or in case of nominal data, maybe something else. For example, if I would refer to a population of heights of 18-year-old males in United States, then those would be numbers. Let's say in inches, somebody would be 70 inches tall. Somebody would be 72 inches tall. Somebody could be 67 inches tall. Somebody could be 59 inches tall. And that way you can have all sorts of different heights over random 18-year-old males. Could be another 67, could be another 70, and so on. And could be many more that is in that population, probably in hundreds of thousands. If we are to collect the sample, we would probably collect only a portion of these, and that portion would be the data in our sample. So sample is just a portion of the population we collect. And again, population is not something that is made out of living and breeding individuals, but rather set of numbers, collection of numbers. Those numbers have some meaning to us. They have some description. So we call that meaning a variable. So for example, in this particular case, I would say the variable is the height of 18-year-old males in United States in inches. It will be very precise description. Now the variable could have values. One value could be 59, one value could be 67, one value could be 70, and so on. So the variable has values. Those values are called instances. Instance of a variable would be a particular numerical value of a random 18-year-old male. The variables themselves could be discrete in case we are able to count those values. Now in the case of height, we usually are not able to count those values. We can only approximate. So nobody is really 70 inches tall. They're probably somewhere between 69.5 and 70.5 inches tall, and we approximate that to 70. But in some cases we can count, like the presence of students in my class. It could be 1, it could be 2, it could be 15, it could be 27, it could be 0, right? If nobody comes to class. And those kind of variables are called discrete. when we can count the values. When we cannot count the values, or the values are only in ranges, then we call them continuous. Variables could also be dependent or independent, dependent on some other variables. For example, if I am talking about the height of 18-year-old male, as I have this example, then this variable, the height of 18-year-old male, would be dependent on the weight of 18-year-old males, and vice versa. It would probably not be dependent on an IQ of 18-year-old male, right? So those two would be independent, while the weight and height would be dependent. We will talk about this a little more down the road in our course. The sample that we collect from a population could be collected in a couple of different ways. It could be collected by observation, and that doesn't mean just by looking at something. It means it could mean a lot more work. For example, if I am to collect mileage per gallon for vehicles in the United States on the road, I might want to go to Walmart parking lot in the Commons. There I would probably carry a blue book that could help me to identify the car model, and I will write it down, and I will go back home. I would search on internet, government website, fuelefficiency.gov. There I would find the mileage per gallon for a particular model that I have recorded while I was in the Walmart parking lot. That way I would collect maybe 15, maybe 100 numbers that would be mileage per gallons for those vehicles that I was able to record. So there's a lot more work than just observing something. Now, that's one way of collecting the data. Another way of collecting the data would be by a way of experiment. The difference between these two is that when you collect the data by way of experiment, the one that collects the data is the one that has a direct impact on the data he collects. For example, if we are collecting information about a tumor gain in mice, we probably already injected that mice with some kind of genetic material or maybe a toxin, and in that manner we are actually influencing the data. Sometimes this is done by testing drug effectiveness, in which case we usually divide samples in two groups, what we call experimental group, where we have direct influence on the data by giving the people a particular drug, and control group, in which in that group we would not have an influence other than psychological, right? So we would give to those people in the control group what we call a placebo, as in sugar pill, something that would not be a drug. So in that case, in the experimental group, we have a direct influence on data, and we would probably want to do that so that we could compare the effect of drug. Then we could also collect data by simulation. This is done when the actual data, to collect the actual data would be too expensive or legally impossible, or impossible in some other way. So for example, we could simulate casualties in one megaton nuclear attack by using a computer program in which we would probably need to have some information about topography, about geography, about climate, about population density, the structures, and so on. In that case, of course, we could not collect real data. The casualties in one megaton nuclear attack could be horrific, so We would not be able to do that, but we would be simulating the event, and in that case we would collect the data by simulation. So in this particular case, the data is not real, it's virtual. We could also collect the data by a way of census. When we collect the data by a way of census, that means that the sample we are collecting is very close to the size of the population. Maybe an 80% of the population, maybe 90% of the population, in some cases exactly as big as the whole population. For example, SAT scores. There is a service that keeps, business service that keeps all of SAT scores. A company called Educational Testing Services, which is, I believe, in New Jersey, and they have all of the SAT scores, so they could actually tell you everything about the whole population, about the state SAT, state of New York or something else. But when the government does that every 10 years, they are not getting the whole population, they're getting maybe 80%, maybe 70% of the population, but it's still a large chunk of the population, so they call it a census. They collect all sorts of different information. For example, personal income would be one such information. Every sample, no matter what, will have a bias. The bias of a sample is the defect of a sample. No matter how nicely the sample is collected, there will be a bias. There will be a defect of a sample that would make sample deviating from the population. Intention of collecting a sample is to get something that is representative of the population. Now, in case the sample is not representative of population, we have some type of a bias, and that's a defect of a sample. We can measure that numerically, but we are not going to discuss this particular type of a measure in our course. When the data is collected, the data could have different types, different levels of measurements. It could be nominal, meaning something that doesn't have a numerical value. I already mentioned there could be a color, there could be a zip code. It is a numerical value, but without meaning, other than a location, right? It could be a gender or something else. The data could have an ordinal level of measurement. This is very often done in customer satisfaction or in grades. So, for example, in customer satisfaction surveys, you usually have to select among 5 numbers to express your satisfaction with the service. 5 would be excellent service, 4 would be very good service, 3 would be good service, 2 would be sufficient enough service, and 1 would be unsatisfactory. So what you would say is that 4 is better than 3, but you cannot possibly quantify that. So you cannot say this service is 30% better than some other service. And I mean, it's very difficult to do that. So the numbers have only the meaning in the way they are sorted. The bigger number means better satisfaction, right? The higher satisfaction. So the data level of measurement is ordinal, as in you can recognize the order. 2 is definitely lower quality service than 3. The data could also have interval level of measurements. So, for example, talking about the outdoor temperature, we can say the outdoor temperature is during the winter months probably 30 degrees in New York. During the springtime might be 70 degrees and could be 75 degrees. And all of those numbers mean something, not just by saying that 70 degrees is higher than 30 degrees, but you can also notice the interval as a meaning to you, right? It's 40 degrees warmer, and 75 is only 5 degrees warmer than 70, so both are very pleasant for outdoor stroll, but the difference between these two, the interval difference, is only 5 degrees, and that's not much of a difference, while the difference between these two is 40 degrees, and that's a significant difference. So notice this is quite different than what we had in the previous level of measurement. So the difference between 4 and 3 is the same as difference between 3 and 2. It's really meaningless. We could as well use 10, 20, 30, 40, and 50. It will mean the same to us. While in this particular case, the difference between two numbers, the interval between two numbers, is meaningful, and it means something to us. And finally, we could have the highest level of measurement, something we call ratio level of measurement. This is a level of measurement when we can actually make ratio between two data values. For example, if somebody has an $80,000 income, annual income, that would be one item in our sample, and another person could have $60,000 annual income, another item in our sample. We can divide that by dividing bigger with smaller or smaller with bigger. In either case, if you divide bigger with smaller, you end up with something, I believe, 1.33 approximately, right? So I have to say 1.3 with a bar over 3. That would mean that $80,000 income would be about 33% higher than $60,000 income. Vice versa, if I divide 60,000 with 80,000, I would end up with 0.75, which means that this lower income here would be 25% smaller, meaning that I could divide two numbers and have some sense out of that. In case of temperature, you would not be able to do that. For one thing, you can have a temperature that is 0 degree. So if you divide 30 with 0, you will not be able to get any result. On the other hand, you can divide 0 with 30 and you would have 0. That would also mean nothing. I cannot make any sense out of that. You can also have a negative temperature, which would be even further harder to figure out what would the meaning of negative ratio between two temperatures be if you have to divide a positive with negative. So it doesn't have any meaning in terms of ratio. So the outdoor temperature in this particular case does not have this ratio level of measurement. Again, what we are trying to accomplish is to get the level of measurement as high as possible, but sometimes it isn't possible. If I'm collecting data about gender, I cannot make that data numerical other than by a face value. You can say 1 for male, 2 for female, 3 for something else. But to us, those numerical values would be just a distinction. It would not mean anything in particular. Okay? Here I would like to stop, and the next video, the part 2, will be about what kind of samples we have. We'll talk about that.